Welcome to the Code with Jason meetup. I forgot to hit record as I sometimes do. We're doing robotics programming this evening, and right now this robot is calibrating itself. So I had built a prototype of this, just the mechanics, no motorization. And once I got the mechanics kind of figured out a little bit, I added some motors. But then once I added a motor to this joint here, that I could turn the motor on for a period of time or for a certain number of degrees of rotation, but it didn't have a way of knowing in which direction the arm was oriented. And so I'm like, how can I figure that out? I couldn't really figure it out, so I asked ChatGPT, and ChatGPT said you could add a couple physical barriers. And I thought that sounded like a good idea. And so I made it so the arm can travel 90 degrees to the right, and then it gets blocked by the physical barrier. And then it travels 180 degrees to the left and gets blocked by the other physical barrier. And since that sweep of motion is 180 degrees, it can then rotate 90 degrees, and then it's pointed straight ahead and it knows how it's oriented. And since that measurement has been made, then it knows from that point on how much it needs to go to get pointed what direction. And once I had that working, I'll just make it do it again. I did a similar thing with this other joint here, but instead of 180 degrees of motion, that one only has 90 degrees of motion because it only really needs 90 degrees, and it would have made things more difficult to make it 180. Okay, so again, it went to the right until it got stuck. Now it's doing the 180 degree sweep until it gets stuck on the other side, which will happen shortly. There it is. And now it'll go straight that way. There it is. Now this one's calibrating itself. You couldn't tell, but it tried to go this way. Oh, wait. It is broken. The motor's moving, but the robot is not moving at all. Yeah, you can see that gear moving, but the arm is not moving. So we have to do a little bit of physical troubleshooting right now. Oh, I see what the issue is. Okay. Let's do this one more time. Oh. And don't be shy. If anybody is not getting it, probably because I'm explaining it poorly, don't be afraid to ask me to explain part of it in a different way or something like that. Okay, it's almost done with its 180 degree sweep. It's going to get stuck. It's going to go to straight ahead. Okay, now, see, it goes all the way down until it gets stuck. Okay, now it's stuck. Now it's going to go up to this direction, I think, anyway. It absolutely didn't. All right. Let's do it again and see what happens.
It looked like it started, then stopped.
Yeah. So I don't know if that's due to a mechanical issue or a code issue.
A reboot fixes all problems.
What's that?
Just reboot it. Fixes
there we
all
go.
problems.
This joint's working perfectly. This one gets calibrated perfectly every time. Okay, but whether this next one works or doesn't work, we'll start looking at the code either way. Okay, so it tried to go this way and then got stuck. So it knew it was at the down position because it got stuck. Now it's going to go up to here until it gets stuck. Okay, it has now calibrated itself. So the fact that it can work tells me that it must have been either a mechanical issue or an issue where with the code where I made some kind of logical error where it only works if it starts in the almost straight down position. We shall see. But anyway, I'm going to share my screen and we can look at the code. Okay, I'm going to open the file. Okay, sorry, before we look at this, I left my Git status in a dirty state last time so I could see what we were doing. But I guess before we even look at that stuff, we should take a quick look at the code. Okay. So I'm trying to decide how deep or not deep I want to go into this. But kind of the main thing is this calibrate function here. And a little bit of a vocabulary is probably necessary. So this joint here is the base joint, that first joint that was getting calibrated. And then this joint is the shoulder joint. Then there's going to be like, later on, there's going to be a wrist joint. That's why these things are named out. There's going to be an elbow joint and a wrist joint. But right now, we don't have those parts yet. So you can see the way the whole machine gets calibrated is it calibrates the base joint, then it calibrates the shoulder joint. And how does one of those get calibrated? Well, we have a class called base joint and a class called shoulder joint. And sorry, bear with me a second here. Okay. Shoulder joint has a calibrate method that I'm not going to go into detail on yet. Base joint also has a calibrate method. We will naturally end up going deeper into this stuff shortly. So I don't want to go into it now and just probably kind of bore everybody. Okay, so the first thing I want to do is figure out what we were in the middle of last time and get that kind of get that buttoned up before we do something new. So to be honest, I have no recollection of what we were doing before, but I think, Jonathan, tell me if your memory is different, but I think the last thing we did was we were just kind of renaming some things.
Yeah, there was renaming a few things, and we wanted to make the move to beginning and move to end kind of be a little more similar. And calibrate, yeah, so what we're doing to calibrate is really was just going to be setting the range, then moving to a known position.
Yeah. I'm going to see if that code matches the code that's actually running on the robot. Beginning of rotation range, end of rotation range. Okay, yeah, looks like it is. So I'm going to commit this and I'm just going to say refactoring. Okay, now we're at a clean working state. So I had a brilliant idea, Jonathan. I almost emailed you after our last session because I was like, oh, this is it. But I decided not to bug you. I had the idea that we could have a class called range. So how would that help? I don't remember. All I remember is I had the idea for a class called range. So let's see if we can figure out how that might help. Oh yeah, see, Jonathan, I added this comment after the last session that said maybe there should be an object called range. So I'm guessing that I put this comment close to where I was imagining the range class would be used. So just to make sure you guys understand, when I talk about range, when we talk about range, that means like the range of freedom of each joint. So like this base joint, it has 180 degrees of freedom. and this shoulder joint has 90 degrees of freedom. So that's what I'm talking about with the range. And the idea with the calibration, we don't know where the arm is going to start. So we can't just assume that we're at the very limit and go 180 degrees. We have to get ourselves to the beginning so that we're starting fresh when we do that 180 degree sweep. Okay. Maybe what my thought was, Jonathan, was like move to beginning of rotation range. I think I saw all this stuff. It was like move to middle of rotation range, move to beginning of rotation range, move to end of rotation range. It's very repetitive. And sometimes I find that when I have a repeated idea like that, it's maybe a sign that there's a concept waiting to be born. And so maybe it's the idea that a base joint has a range, and we do like range dot move to beginning, something like that.
So one of the questions I had when I was thinking about this too is the difference between the shoulder joint and the other joint. Really, it's just the range, right?
Yes. I mean, that question could be answered with a no also, but I think for the purposes you're asking, I think yes.
So I'm just thinking about if you kind of solidify the concept of a range, then that almost gets rid of the need for those subclasses.
Which subclasses?
So you have the shoulder joint subclass, and the other, what is it, the wrist joint?
Base joint.
Sorry, you've got
It is kind of confusing because base joint, you might see base joint and think that it's a base class.
Sorry, I thought that there was inheritance going on there.
For that reason, I've also heard it called a waist joint. And that might be a better name. I'm so sure that it's a better name that I'm actually just going to change it.
But Jonathan, to your point, there is inheritance.
There is, but I think he thought that base joint was the base joint class, when really the base joint class is just called joint.
Yeah, so so the shoulder joint and the base joint, besides their range, how are they different?
Good question. Let's look and see what the answer to that is. Maybe the answer is nothing. I'm going to run my test suite before I commit this. And
Because
while that's sorry,
if they are the same, then really what I'm seeing in there is that their range is different, and then potentially their like home position is different. So you have that one go to the -90, and I don't know what actually they're both going to -90.
yeah, but that's only incidental. Because for one, -90 means center, and the other one, -90 means straight down. So it's just a coincidence that it's the same number. Okay, something seems wrong. Maximum recursion depth exceeded. Okay. Line 37. Okay, I don't know why that's happening. I'm going to undo everything I just did. And I'm going to paste this older version of the code in, and I'm going to see if that works. Because I don't know for an absolute fact that the code even worked before I did that waist joint change. I wish I could make it do this faster, but it can't. Okay, is this gonna work? It looks like it is. Maybe not. Didn't get the same error. Okay, I'm gonna run it yet another time, but I'm actually gonna just have it calibrate the shoulder joint and that's all. Because I think the shoulder joint stuff is pretty safe. Yeah, it got stuck right there. Interesting. I'm gonna do that one more time. And now it's working. Okay, so something's not quite right. Ugh. It keeps slipping now. Oh yeah. Mechanical issue. So, okay. It's like it's ripping itself apart when it gets to a certain place. Okay, I will just have to make sure from now on to like do some preventative maintenance each time it runs so that it doesn't rip itself apart like that. Okay, but I don't think the code has been changed. It seems like this bug that exists with this shoulder joint not getting calibrated properly, I think that's a pre-existing bug. I don't think that's been introduced recently. Okay, so I'm gonna replace base joint with waist joint. Then I'm gonna replace that base joint with waist joint. Now I'm gonna paste that in. Again, I'm gonna comment the, oh, no, okay, I'm just gonna run it as is. All right, so now it's calibrating the waist joint, and that's the one we renamed. And this seems to still be working fine. Okay, and then let's see if we get that error we got last time or if it works. It seems to work. Okay, so I don't know what mistake I might have made last time, but if I made a mistake last time, apparently I didn't make it this time. Yeah, this is really all right, well, some other time I'm gonna have to go and redesign that part. Where the gears mesh together, one gear like pushes against another gear, and the housing of the gear just relies on friction to keep it in place, and so it slips. So I need to not rely on just friction, but actually put something holding it down. Anyway, we can commit this rename. Okay, rename base joint to waist joint. Quick teachable moment here. Basically every code base I've ever seen has something like that, you know, like where it's called base joint, and it was confusing because it seems like it means base class or something like that. Like every code base has confusing, misleading things like that, but sadly usually they don't get fixed. But I think it's very worth taking the effort to fix those things because the cost of fixing it is usually way less than the cost of living with that defect in the code for the indefinite future. Okay, so Jonathan, picking back up where we were, you asked what's the difference between shoulder joint and waist joint. I think part of the difference, Jonathan, is that we refactored waist joint to make it a little bit nicer, but we have not yet done the matching refactorings on shoulder joint. So if we want to unify these two classes, which I think we do, usually I like to first make them so they're like almost identical and then merge the code. So maybe let's do that. We had this term before, discard sweep, which was kind of not the clearest. I think we had decided last time, because what we really are trying to do is we're just moving to the beginning of the rotation range and then moving to the end. So you know, I feel confident enough that we can just actually blow this away in shoulder joint. I'm going to copy waist joint verbatim. Okay, and let's go through this code and see if we think there's any reason why it wouldn't work for the shoulder joint. We know it's working for the base joint. So how do we calibrate it? First, we get the range. Okay, how do we get the range? First, we move to the beginning of the range. Okay, that seems fine. Then we move to the end of the rotation range. That seems fine too. And then we move to the middle of the rotation range. But that's a misnomer. But I'll keep it for the moment. I'm just going to give this a swing and see if it works. And we wait again. If anybody has a good joke or something, now would be a good time to tell it.
And you thought capybara was slow.
Ha! It's a good one. Why didn't the skeleton go downhill skiing? He didn't have the guts. Okay, waist joint calibration is almost complete. There we go. Okay. That seemed to work just as well as before. All right, so what I just did was I copied the code from the one class to the other so that they're more or less identical. I think they might be exactly identical. So it's very duplicative right now, but I'm going to commit that because it works. And now I'm going to try to deduplicate it. The reason I wanted to commit that is because what if I mess up the deduplication? I don't want to have to lose that work that I just did. So we can possibly move most of this stuff to the parent joint class. Let's even just move like all this to there. Okay, so now waist joint and shoulder joint don't even have any of their own behavior. They just have different configuration. That argument is the joint name. They just have a different joint name and that's all. So let's see if that works. Okay, waist joint calibration works. Shoulder joint seems to not be working. Interesting. Okay, so let's do this again. Let's comment out the waist joint part and do just the shoulder joint and see what happens. Yeah, something weird is happening. I was going to say I have a guess, but I don't. Well, in these situations, I usually don't try to figure out what's wrong. I usually just revert back to a working state and start over, but more carefully. So I reverted my change just now. And now I'm going to run the code to see if it works, but I'm going to skip the waist joint. Okay, yeah, it works again. So here's what I'm going to do. I'm going to take everything from just shoulder joint No, you know what? I'm going to take just calibrate and I'm going to move calibrate to the parent class. I'll do a git diff so you can see this clearly. This is confusing. Took away waist joint and added waist joint. Oh, I think it's one of those things where Git like doesn't understand that something got moved from one place to another. So what I did though was I just moved that calibrate method instead of having the calibrate method defined in both waist joint and shoulder joint is defined just once in the parent joint class. So now I'm going to run this and see if that works. I'm going to turn down the heat in my office because it's getting hot. Okay, so the waist joint calibration seems to still be working. By the way, I ate a huge amount of Mexican food and ice cream right before this meeting. A terrible choice. I feel like I might fall asleep. Okay. Oh no. Something just fell off. It seems like it was an important part because now it's not working. It's hard to get to also. Okay, hang on. Oh, I found it. It was this little gear piece. I think it goes right here. Oh no. Okay.
just going to mention, Jason, that
Mhm.
that shoulder joint's been a little bit flaky, which would probably be another condition that wasn't included in your possibilities for flaky tests.
Yeah, that's true. I didn't account for mechanical issues.
Are you using different power for the different joints or no?
Same power,
That might not be good.
maybe you're right.
Physical constraint.
Okay, let's see what happens now. Okay, so it is working now. Yeah, so this is an interesting lesson. Just because it works once and just because it works twice doesn't mean it's going to work 50 times, which is a bit different from code, you know? If it works twice, it'll probably work 50 times, but mechanical stuff is a bit different. Okay, so I'm satisfied that this works. So I'm going to commit this. I'm going to say move calibrate method. Okay, so now I'm going to move another one. I'll move get range. Okay, so now instead of 2 get range methods, there is only 1. It's hard for me to find time to work on this because we built a Lego room for our kids a few months ago. It's right over this way. But whenever my wife comes out here to this building that the office and Lego room are in, she finds me in the Lego room, she gets really mad. So I have to be very careful.
No, dear, it's for work.
Right. I told her that last time I was working on it, and she's like, that's barely an acceptable reason. So I don't think that would work very many times. Okay, so things seem to still work after moving that method. This is a bit of a painfully slow process, but it sure beats having a mysterious failure and trying to rack our brains for what went wrong. Okay, yeah, we move get range method. Okay, so I'm going to move 2 methods in one go now. I'm going to move to beginning of rotation range and move to end of rotation range. Okay. Yes, let's try that. Okay, so all we have left in waist joint and shoulder joint is move to middle of rotation range. And as we can see, they look perfectly identical to me. So it's surprising that when we moved those two, things didn't work anymore. It could have been something
think
completely unrelated.
When you copied I think it was the shoulder joint, you copied that whole class and you put it into waist joint. But I don't think you renamed the def in itself. In this case, would have been line 98. So you had 2 shoulder
Okay.
joint.
Oh, really?
I think that seems like what I saw. I don't know.
Well, do you guys see what just happened? It seemed like it calibrated the waist joint, but not the shoulder joint.
The shoulder joint's been flaking out a whole bunch tonight. If you run it again, will it work?
Let's see. All right, I'm going to try just the shoulder joint. And I think what I want to do is make the code easier to understand and then troubleshoot this issue. So that certainly seems to be working. All right, I'm going to run it again, but with the waist joint calibration also. Yeah, I wonder why the shoulder joint would work sometimes and not work other times. Okay, it's working. All right. So apparently it just sometimes doesn't work for reasons that are not plainly observable to us. Okay, move more methods. Okay, the final move. Move to middle of rotation range. And something else I'm not super happy about is that I have this like joint config up top. And then I have to like load in the joint config. For some reason that feels weird to me. But I don't know what to do about it. And maybe it's not even a real problem. Okay, moment of truth. Okay, it's working. Okay, move to middle of rotation range. But again, that's a misnomer because the waist joint really does move to the middle of the rotation range, but the shoulder joint moves to the extremity of the rotation range. So I think we want a different name for that. We want to call it like the starting position or something like that.
Last week, they referenced like a home position.
Or yeah. Or neutral.
Yeah.
Yeah. Neutral's good too, Rob.
Okay. Okay, maybe I'm not even going to deal with that yet. Okay, so waist joint and shoulder joint are basically empty. Now let's look at this base joint class, this parent joint class. Now, way back, Jonathan, at the top of the show, you said something like our waist joint and shoulder joint even doing anything different. Now we have kind of unified them. Did you have a specific idea for something we wanted to do after that? Or were you only pointing out the fact that they were almost the same? Or was it something different entirely?
Well, this is coming from when you said is the range a concept. And to me, really, and even you saying that you that configuration at the top was kind of smelly to you. that to me kind of sounds like it's the joint class is going to take like some parameters for your range and your what your home position degrees are or something like that, and really that's your
Oh, yeah.
configuration, and actually the port number that it is.
Yeah, so
Um,
maybe like the configuration should get passed when it gets initialized.
Yeah, so I'm seeing something like waist joint equals joint point port A range 90 270, something like
Yeah.
that. But what's that
Okay.
adjustment in degrees?
Good question. That compensates for mechanical imprecision. My memory is that like when it goes to 90 degrees and then to 270 degrees, it actually goes maybe to like 93 degrees and 267 degrees or something like that. Like it's a little bit overly wide. And so I had to add an adjustment so that, oh, it's not even being used anymore. But I had to add an adjustment to make it go perfectly straight. But maybe let's take that out of the picture for now, because like that's just kind of a confusing, distracting thing. And again, I'm not even using it anymore. So screw that. Take out adjustment. Okay. So I mentioned I was unhappy with this config stuff. Now we have all this. It's kind of like a feature envy thing. Like joint doesn't feel like it's mostly about a joint. It feels like it's mostly about a range of a joint. And that feels inappropriate. Like it's confusing when there's a class called one thing, but then it's like 80% about another thing. So let's give this a try. Let's have a class called range. Let's see. Range equals range. Oh, range might be some kind of a reserved word in Python. So instead, maybe let's call it a joint range. Might be a better name anyway. Range is very broad, ambiguous. Okay. In Python, when you don't want to, do you just, no, not pass. What do you put when there's no implementation? Does anybody know? Okay. Let's ask ChatGPT. In Python, what do you put when there's no implementation? And we'll wrap it up in just a few minutes here, by the way. Okay, pass, but it's lowercase. Okay. 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 So I think I'm just going to do that much. I didn't change any behavior. All I did was introduce this class. Just going to make sure I didn't introduce any syntax errors or something like that. And while that's doing its thing, we can make this a little bit different. So one of my coding principles I try to follow is keep everything working all the time. So I don't want to get this into a non-working state. I want to keep it working at every step of the way. what is self.range? Like, where is that used? So we initialize it to nothing. Okay, and then it's this. Okay. But what if range is not a number, but it's rather an instance of the range class, of the joint range class? And so we can do something like self.range.value.
I think that range is a different thing though, maybe. Because like, are we thinking the range is from 90 to 270? Because that other self.range, that's like the number of motor ticks that the range is, or something like that, isn't it?
Yeah, let's see.
That's like the degrees of sweep.
Yeah, and we have an ambiguity in this program, which we talked about last time. There's like degrees of the motor rotation and the degrees of each joint rotation, and they're not the same thing. Because there's like a lot of motor rotation. Well, the ratio of motor rotation to joint rotation is not 1-to-1. There's more than one motor rotation there's more than one degree of motor rotation per degree of joint rotation. And so for this program to talk about degrees is confusing because it's like, well, we're talking about degrees of the motor rotation, or we're talking about degrees of the joint rotation. And I personally am confused right now because we see sweep.total degrees, but it's like, what kind of degrees is that? Is that degrees of the motor or degrees of the joint? Okay, so let's figure that out. The total degrees of a joint is this long thing. This seems kind of hard to understand. Okay, for step in successful steps, okay, we sum all the successful steps. Maybe we want to refactor this. Okay, let's forget about joint range for a second. And let's focus only on this total degrees thing. Okay. I'm going to have ChatGPT help me because, you know, you try coding after you've eaten 2 gigantic burritos and a bowl of ice cream and my son's leftovers. It was just way too much. Like 1 burrito would have been like a full dinner, but I ate 2 and rice and beans. What I'm trying to say is I'm in rough shape right now.
How many chips while the food was coming to?
Chips? Oh yeah. I ate not a lot of chips. We got takeout, so didn't have to sit there and wait. Okay. Help me break up total degrees into like 2 methods. Let's see what it does. No, I don't like that. I think what I want, sorry, I'm going to make this smaller so I can actually like see the whole thing. What I know I don't want is I don't want a line that's like so long that I can hardly see the whole thing. And even if I can see the whole thing, like this is just too long to be easily understandable. It's like I'm seeing these implementation details, and I'm having to synthesize the greater meaning based on these details, and that's just too hard. That's too much to ask of the reader. So I want to add some abstraction to this to give it some meaning. So maybe like, what's this sum thing all about? I'm summing up Okay, the successful steps, it's like the total length of all the successful steps. Okay, no, I don't like that. How about one of the methods returns the sum of all the successful steps? Okay, why did it create something called joint range? Oh, because it thinks I'm still talking about this. No, ChatGPT. Okay. Some degrees successful steps. But what's the meaning of the sum of the degrees of all the successful steps?
So I know you put up there degrees move greater than 10, so it's taking significant movement and then considering that, and then it's summing it against some other thing, and then it gets an absolute value. That's unsuccessful steps. And that's part of that long equation on total degrees, I think.
Yeah.
Yeah.
Yeah, so like if the step was just like if it got stuck, then that step failed. It was not considered successful. So this 10 degrees is just an arbitrary number, which I should fix. I should put that in the constant, but it's just an arbitrary number. So we're taking all the steps that weren't failed, all the steps that were successful, and adding them up. It's the successful steps of the sweep, and then it's like the degrees moved in the sweep. Okay, but why am I taking the absolute value? That's because we don't care which direction.
Correct.
Yeah.
And you're somewhere in that joint config step.joint, you're saying one successful step is this many degrees on that joint.
Because it could also be negative degrees. That's probably why.
Yeah, depending on direction moved, but
yeah.
Okay. I think one thing I at least want to do is this. Okay, length of one step in degrees. What is that anyway? Oh, negative 50. Interesting. Okay. I'm going to call this length of one step. I'll call it, for consistency, I'll call it length of one step in degrees. Okay, and I did that just to see, I just wanted to get this noise out of there of this config related stuff. Let's see if this makes a big difference. Some of the length of one step in degrees for step in successful steps. It's almost like I want to do, oh, here's what I want to do. Step dot length in degrees. I think I want to do that. That seems easier to understand. And so step. Do I have a step class? Yeah, I do. Okay, so I can have a method called length in degrees. Self.joint. Yeah. Okay. Return the absolute value of the sum of the step.length in degrees for step and successful steps. I think that's at least better. Maybe it's not perfect. This doesn't make me jump up and down for joy, but it seems at least better. So let's test it. And if this works, we'll call it a night and pick back up next time. And if it doesn't work, I don't know what I'll do.
Question for you.
Yeah.
My I don't have much Python experience, but that can you pull up that
Yeah.
that line? So where you're doing so the actual
Yeah. Where the heck
step
is
dot
it?
length?
Oh, there it is.
Yeah, so on 42 there, is that basically getting the number of steps that were successful times the length in degrees, since that's a constant?
I think I missed part of that, but I don't think it's getting the number of steps. I think it's getting the sum of the return value of length in degrees for all the steps. It's like a map. It's like a Ruby map.
But since it's a constant, couldn't you
Sorry,
just
it's not like
go-
Ruby map, it's like Ruby sum. But sorry, say that again. So since it's a constant.
couldn't you just multiply the length, the number of steps times the length in degrees? Or is each step going to be different lengths?
The steps will potentially be, no, hang on a second. It's complicated because it depends on how precise you want to be. Yes, technically the steps will not all be the same length, but what I'm doing here is an approximation, because like maybe 10 steps happened and they were each like 43, 48, 44, there was some like number that was not quite 50. But it's a precision that doesn't really matter. And so for simplicity, I'm just taking the number of steps and multiplying it by the ideal number of degrees, not the actual number of degrees. But maybe that's not smart. Self.degrees moved. Yeah, like each of these steps has a degrees moved. There's no reason I can't use the real degrees moved. Not as far as I can think. Let's give that a try.
You need a parenthesis on the...
No, because that's an attribute as opposed to a method. And I think the shoulder joint, oh yeah, we got this mechanical problem again. Don't worry, I think I can fix it on the fly. There. Okay. No. Okay. Well, that moved to very much the wrong place.
Mm-hmm.
Let's see if this one does the wrong thing too. Yeah, it's hard to tell if I did the right or wrong thing. Okay. Well, what an unsatisfying place to end. But I think what I can say is this, like the code is too confusing. I don't understand what's going on. I don't understand why this doesn't work. And what that tells me is that we need to make the code tidier so that it's easier to troubleshoot. And like I said last time, but we haven't gotten to it yet, is we could use some automated tests. and I think that'll help get the bugs out.
Mhm.
So I think next time we can pick back up, let's just revert this, because this state that it was in a little bit ago, that was at least working. So when we pick it back up, we can pick it up in that working state, and maybe we'll want to try to refactor that same part. Maybe we'll want to do something different. But one thing is for sure, before I add any new behavior to this calibration, I want to get the existing code under control, and both working without bugs, without known bugs at least, and easy enough to understand at a glance.
Sounds good.
Okay. Well, thanks guys for hanging with me for another session of robotics. And we're not going to have a meeting next week because it's Thanksgiving here in the United States. So I will see you guys after the holiday. Have a good one.
Happy Thanksgiving.
Bye, guys.
Sure.